Hey guys, take seats. Go ahead and rearrange yourself so you're sitting next to your lab partner. Grab a laptop and get going. Okay, we're starting with experiment 43.
We're watching the characteristics of a solid and the movement.
We're looking at the net motion of a solid state of bromine versus the gas and liquid state. And you can see things that you wouldn't normally be able to see with the naked eye.
We've got solid, liquid, and gas state of argon, and we're measuring the differences in kinetic energy and how they apply to or determine the phase.
We're looking at characteristics for the solid. This is salt right here, sodium chloride. Well, right now we're just looking at like the positions of the atoms in the molecule and like how they are arranged in symmetry. It helps like a lot of seeing things more visually instead of reading it.
Well, for the most part, they're staying in one spot, but they're actually migrating, which is kind of surprising.
Yeah, the white trails tell you that they're migrating?
Yeah, that's where they've been, and it's just marking it out. And I've hidden the molecules so you can see the trails better.
See, they're staying in the same place, but they're slowly moving across the thing, as were the solids. They're not even veering off the path. They're just staying in that same dot, and the gases just they're all over the place.
Moving faster than the attraction can overcome. So there's more attraction and less kinetic energy in solids, so they come together as a solid.
What we've discovered is that gas has no potential energy and most kinetic energy.
Okay.
And whereas solid has the most potential energy and the liquid.
I thought they were going to be different because I thought they'd move like different speeds, or because they're different, or not different speeds, like differently because they're different molecules.
Just look in your eye.
So I expected it to be different, but they both have the exact same potential and.
Oh, there. Why is this false? How would you change that statement to make it true? Do they still move across the container? Yeah. They still move across the container, just a lot more, or a lot slower. Like this is the first molecule you looked at is ethane. It's called ethane nitrile. So it's the molecule as a unit moving to the left, to the right, or to the left, or up, or down, or forward, or back. So that's one type of motion. But in this molecule, there was another type of motion that's called rotation, which is exactly what it sounds like. Seen is something not like this, but something like this. It's kind of random twitching rotation. That the solid has the least kinetic energy, followed by the liquid, and the gases have the most.